So, rational or irrational numbers. These are the definitions. You should have gotten a vocabulary sheet that has all of these. I just cut it, and then notice 7, 8, and 9, I just put at the bottom. So, rational numbers, this is one of your vocabulary words. So, from the topic. So, rational number, a number that can be written as a fraction or as a terminating or repeating decimal. And then if you go down here, if you don't know what terminating decimal is a decimal that ends. So 6.35, 8. Remember, 8, you could really write it as 8.0 or 8.00, like if you're talking about money. 4.005. Remember, a repeating decimal is when you have something like 3.33 repeating, and they have that little bar over the top that says repeating. 5 is an example of a rational number. 6.39 is a rational number. 0.25 is a rational number. The square root, and that should go all the way across, the square root of 16, because it is an exact number. We know the square root of 16 is 4. So that's a rational number. 4 is a rational number. The square root of 16 is equal to 4, so it's a rational number. Okay, irrational number. A irrational number is a number that does not terminate or repeat and goes on forever. It cannot be written as a fraction. So the square root of 5 is not a perfect square. Like 16 is 4 times 4, so the square root of 16 is 4. 5 cannot be rewritten like that. It would be a decimal. Pi, if you think about 3.14, it's 3.1415 ... It just keeps going. And there's no pattern to it. It does not repeat. You would have to memorize every single number. And then any square root that is not a perfect square is irrational. Something I want you to write, and I'm going to put it on a sticky note, and I will probably cut this sticky note. So my easiest way to think about rational, irrational is, could you find, I guess I don't need to write it on a stick. Oh no, that was awesome. So, the question you want to ask yourself is, could you find the, let's say, 1,000th? Could you find the 1,000th decimal? So if you had no life and you wanted to write a number out with 1,000 decimals, if you can find the 1,000th decimal, if you can, it would be rational. If you cannot, it would be irrational. So if you think about 2.5, and I wanted to find the 1,000th decimal, I would know that the rest of those decimals would be 0, and I could get to the 1,000th one, and we know the 1,000th decimal would be 0. If I had 3.33 repeating, and I wanted to find the 1,000th decimal, we know the 1,000th decimal would be 3. If we had 3.14, 15, on and on and on, and there's no pattern, there is no way to find the 1,000th decimal, so this one would be irrational. So if you cannot find the 1,000th decimal, then it's irrational. If you can, then it would be rational. And maybe that helps you, maybe it doesn't. That's just the way I think of it, is if I could find whatever number, really large number of decimal, and I can, then we know it would be rational. If we can't, it would be irrational. Alright, so now square root. We have talked about this before. It's been a while though. So square root, a number that when multiplied by itself gives you the given number. So 5 times 5 is 25. 5 times 5 equals 25. So that's square root. That's another vocabulary word. Cube root. Remember, it's a number multiplying times itself 3 times. This one's multiplied by itself, so 5 times 5. This one is 3 times. 2 times 2 times 2. So a number when multiplied by itself 3 times gives you the given number. So cube root of 8 equals 2, because 2 times 2 times 2 equals 8. When we did these in the past, I would show you to rewrite the cube root as 2 times 2 times 2. You were looking for the number times itself 3 times because of that number right there. So 2 times 2 times 2. The square root of 25 is 5 times 5. Remember, if there is no little number or index written right there, then we know it's an implied 2. So we're looking for 2 of them, and you would say that. Okay, terminating decimal we talked about. It's when the decimal ends. A repeating decimal, a decimal that has one or more numbers past the decimal. Sorry, I tried taping and then I pulled up the letters like I did a minute ago. And goes on forever. So if it's 0.35, I could keep writing it as 353535, because notice where the bar is. If it said 0.3 and then only had the bar above the 5, then only the 5 is repeating. So pay attention to how long that bar is. Okay, integers are whole numbers and their opposites. So you could have -1 and 1 are both integers. 12 and -12 are both integers. Whole numbers are positive whole numbers that start at 0 and count up. So whole numbers are 0, 1, 2, 3, 4, and so on. Natural numbers are whole numbers starting at 1 and counting up. Oh, sorry. So natural numbers, 1, 2, 3. Usually whenever I tell students pick a number, they are going to say a positive number other than 0. So natural numbers are those numbers that you would just naturally think of. This is also known as counting numbers. Counting numbers, and notice it does not include 0. I should have highlighted that. So does not include 0. Okay, remember integers include opposites. Whole numbers are positive. Okay, I'm going to skip over these examples and look at these things first. So I took these and just glued them in. This is just for you to look at later. Remember, when we take any quiz, we always get to use notes. So it's always good for you to have things like this. So a rational number is any number that can be written as a simple ration or fraction. Ratio is also in that. Ratios are fractions. Sorry, people are standing outside my window and screaming. But can be positive or negative, can be decimals that stops or repeats, that has a repeating number or pattern. A fraction is a ration. The word rational has the word ration in it. Okay, irrational, and then there are just examples. Remember, pi doesn't repeat. If it's not a perfect square, or even a perfect cube, it would be a non-example of a rational number. Square root of 25 is equal to 5, so that is an example of rational number. Okay, irrational numbers that can be written as a simple fraction, or that can't be written as a simple fraction or ratio. So an example of a irrational number is the opposite of these up here. So the non-examples would be moved to this. So pi 3.14159.000214369 ... There is no pattern there, so it's not a repeating decimal. Cube root of 125 can be written as 5 times 5 times 5. 5 times 5 is 25, times 5 is 5, so the answer to that one would be 5. It's not an irrational number, it's a rational number. Okay, perfect square. Perfect squares are 2 times 2, a number times itself, multiplied times itself. 2 squared equals 4. Remember, a perfect square is the opposite of square root. So a perfect square, it's multiplying times itself. Square root is finding what number multiplied times itself. So if I took the square root of 4, it would give me 2. So they're the opposite of each other. Perfect cube is a number multiplied times itself 3 times, or to the power of 3. So 2 cubed is 8. 2 times 2 times 2. This one's the opposite of cube root. So the opposite of cube root. So if I was taking the cube root of 8, you're finding what number multiplied times itself 3 times. So it would be 2 times 2 times 2. So the answer would be 2. Oh, I almost ran out of room. Again, these are examples. These are non-examples. And now I want to do a few examples using those vocabulary words. So, if I told you to find the square root of 81, remember square root, you can think about it as a square of 81, and you're trying to find the 2 numbers that multiply to get that. Or, remember there's an index of 2. So if I was trying to find the square root of 81, you want to find what number times itself gives you that information. So square root of 81 can be written as 9 times 9. You could also take 81 and divide by all of the numbers. 2 wouldn't work. 81 divided by 3, that's nothing. 81 divided by 4, 81 divided by 5, 81 divided by 6, 81 divided by 7, 81 divided by 8, 81 divided by 9, and you would get 9. So what you divided by has to be the same thing as what you typed in. So the answer to that one is 9. Okay, find the cube root of 64. This one's a little bit different. So if I took 64 and divided by 2, I would get 32. 64 divided by 3, 64 divided by 4. So now there's 4 here, and then there's a 16 here. Well, what is 16 divided by 4? Is 4. So I could rewrite this as 4 times 4, which is 16, times 4 equals 4. If you go back and watch the video of how to find cube roots, I believe I also showed you to do it like this, using a tree. And if that helps you, then use that. I will have that video available. So 4 times 4 times 4, 4 times 4 times 4. There are 3 4s here. So the answer to the cube root of 64 is 4. Okay, now, is the square root of 101 rational or irrational? Well, 101, if you take the square root So notice I hit second in this button right here that has the square root, 101. It says 10.04. That is not a perfect square. So if you look, any square root that is not a perfect square is irrational. So this one would be irrational. The calculator is just rounding to that many decimal places. So this one is irrational. Okay, if this one, 5.6213, notice the repeating bar is over the 13, so it'd be 13, 13, 13, 13, 13. So could I find, and this is what I always ask myself, remember that little note we put up here, could you find the thousandth decimal if you wanted to for this? Yes, you could, because it is a repeating decimal, so it would either be a 1 or a 3. We would just have to do some math to figure out which one it is. So that means it's rational. Repeating decimals, rational. Repeating decimals, rational. Just make sure you memorize that. Okay, this next one is 89.396457 ... Rational or irrational. There is no pattern here. We could not find the thousandth decimal. We have no clue of what it is. So this one would be irrational, because we could not find the thousandth decimal.